Welcome Year 10s. Hope you're going well today. We are continuing on this little mini series of going over some of the gaps or problems that I noticed in recent tests and exams. And the one that I want to look at today is completing the square and taking it one step further, solving quadratics by completing the square. So I'm going to work through some of the examples from exercise 9.7. You've got to work through that exercise, but I'll do some of them for you, so perhaps you might want to write with me as we do this. I'll try and not go too quickly. Now, when we complete the square, we want to have something like this. This is the bit that we're looking for, an x squared plus something x. You don't want to have a coefficient in front of the x squared, so if there is one, you're going to have to do an extra step, which I'll talk about when we come to one of those. So we focus on that little bit there, that x plus 6, and we're going to do something with that. So what I'm going to do is I'm going to take x and I'm going to halve this number here, so it becomes 3, and then I square it. Now, I'll just quickly go on a bit of a ticky tour here. So if I expand that, I'd get x squared plus 6x plus 9, okay, using FOIL. Now you can see that bit's the same as what we've got up here. But I've got this extra 9. So what I want to do is I want to subtract that 9. And now this whole thing here is equal to that there. Okay, so that's what I'm doing when I complete the square. Now you'll notice that I've also got to add this 8 on the end. And now we've got the exact same thing. Now we're going to simplify all of that left-hand side to give us -1. Right? And now to solve, so that's completing the square. That's all we need to do there. Now when we want to solve by completing the square, what we do is we move the number at the end there, that 1 in this case, across to the other side. So we add 1 to both sides. Then we take the square root of both sides. So we'll get x plus 3 on the left-hand side, and we'll get plus or minus the square root of 1. Now, of course, the square root of 1 is actually just 1. Okay, so I'll rewrite that as 1. And then we can rewrite this to be equals -3. I bring that 3 across, plus or minus 1. And, well, what does that give us? -3 plus 1 is -2. Or -3 minus 1 is -4. And so that would be the two answers for x that make this equation true. Now, what I will do with the next one is it's a similar type question. So we take x, we halve the -10, so it becomes -5. We square that, and then we're going to have to get rid of 25, which is this number here squared. Okay, because again, if we expanded this using FOIL, we'd get x squared minus 10x plus 25. Now that bit there is the same as what we've got here, but we've got this extra 25, which is why I'm subtracting that one. Okay, now we're going to add 15 to that, and we've got 0 on the right hand side. We simplify this, so it becomes x minus 5 all squared minus 25 plus 15 is -10. So that's our next line. And what we'll do now is we'll move the -10 across, and to get rid of a -10 from that side, we've got to add it. So we add to both sides. Now we're going to square root both sides. So we get x minus 5 is equal to plus or minus the square root of 10. And then we put the 5 across by adding it, so we get 5 plus or minus the square root of 10. And what does that give us? Well, 5 plus square root 10. If we do to 3 significant figures, we'll get x is equal to 8.16. Or if we take away the square root 10, what do we get? Chuck that in the calculator. What are we getting? 1.84. Okay, so those ones are the easy ones in set 1. But when we move to 2, things get a little bit more tricky. So Why do they get more tricky? Well, let's have a look. What happens here when we try and halve that 3? Okay, so we can just write it as a fraction like this. Now, when we expand that, we'd get x squared plus what's that? 3 over 2 x, 3 over 2 x, so that would be 3x. And then when we square the 3 over 2 times 3 over 2, that's 9 over 4. So this bit is the same as that bit there, but you'll see we've got this 9 over 4. So we're going to take away 9 over 4, which is 3 over 2 squared. So we take away 9 over 4. Then we've got this plus 2 here is equal to 0. So when we go and to simplify that, well, that 9 quarters plus 2 is going to be negative 1 quarter. You can check on your calculator, but think about it. Negative 8 over 4 is negative 2, and you've got that extra negative 1 over 4. So the next line I'm going to write is x plus 3 over 2 squared equals, minus 1 quarter equals 0. We bring the 1 quarter across, and we can do that by adding 1 quarter to both sides. So we should come up with that. Now we're going to square root both sides. So when we square root 1 over 4, what do we get? Well, another way of writing this, when you square root a fraction, like if you square root a fraction, that's like square rooting the top and dividing by the square root of the bottom. Now square root of 1 is 1, square root of 4 is 2, so it's 1/2. Okay, so, but you can do it on your calculator if you're a little bit concerned. So when we square root both sides, we'll get x plus 3 over 2 on one side, plus or minus square root 1 quarter, which, as we've found on the calculator, or by logic, is 1/2. And therefore, x is equal to, we bring that positive 3 over 2 across by subtracting it, plus or minus 1/2. And if we think about that, if we add 1/2, we'd get negative 1, right? Negative 1.5 plus 1/2 is negative 1. Or if we subtract it, we'd get negative 2. Okay, so that's how you do these ones. We've got another example here, which I'll go a little bit faster through. We're going to go x plus, and then we have the coefficient of the x, which is 1, so half of that is half. We square it, and then we subtract. What's half squared? Well, that is 1 quarter. So we subtract that, and then we've got that minus 10 there. Well, when we go minus 1 over 4 minus 10, we can write that as minus 41 over 4. Okay, so we're going to go x plus 1/2 squared minus 41 over 4 equals 0. Now we move that across by adding it to both sides. So we come to this point here, and then we square root both sides. So we should get this, while x plus 1/2 is equal to plus or minus the square root of 41 over 4. And another way of writing it, I'll just put that over here, would be square root 41 over, what's the square root of 4? 2. So we could write it like that. And you can check that on your calculator if you go square root of 41 over 4, and it'll rewrite it for you as square root of 41 just over 2. Okay. Then we move down to our next line. We're going to get rid of that 1/2 by subtracting it. So we get this 41 over 4. Now what does this give us? It's going to give us two answers. Plus, what is it? Square root 41 over 4. Now, this will give us 2.7. 2.70. Now, if we subtract it, what do we get? Check it on your calculator. I'm getting, I think it's negative 3.70. I think those are the two answers there. Hopefully I haven't made an error. Okay, now we can ramp it up a little bit more. Let's say we've got this example here. Now, I told you at the beginning of the lesson today that we don't want a coefficient in front of the x squared. So what we do in these cases, and listen very carefully because there's a few in set 3 where you have to do this, we divide the first terms, the x squared term and the x term, by 3. And then we put in some square brackets. So it's kind of like factorizing, right? Well, and then the second term would be 5 over 3x. Now let's think about why that is. Well, 3 times x is 3x squared, and 3 times minus 5 over 3 is minus 5, right? Okay, so that's why we do that. So that's our first step with these. Okay, get that down. Now, once we've got to this point, we can actually complete the square within those square brackets. So now I start completing the square. Now I've got a half 5/3. Well, half of 5/3 is 5/6, right? So what you do when you're halving these fractions here, just double the denominator, right? And leave the numerator the same. That's the little trick to halve them. Okay, and then we square that, and we've got to subtract this one squared. Now what is 5/6 squared? 25, 5 squared, over 6 squared, 36. So that's quite easy, isn't it, really? Okay, and then we put our square bracket round, and then we've got that minus 2 hanging out over on its own there. And then we're going to expand the bracket. So 3 bracket x minus 5 over 6 squared. Now we've got to do 3 times 25 over 36. What the heck is that? That's 25 over 12. So it's going to be minus 25, because you can see the 3 will cancel out some of the 36, right? Over 12. Minus 2 equals 0. So we go that minus 25 over 12 minus 2. And that gives us, let's just chuck that in the calculator. You can do that. What do we get? I'm getting minus 49 over 12. So we'll get 3 into x minus 5 sixths squared minus 49 over 12 is equal to 0. And now we go about our usual business. We go 3x minus 5 sixths squared. We move the 49 over 12 this way. Now we've got to get rid of that 3. So what we're going to do is divide both sides by 3. So when I divide that by 3, you can see you're going to get 49 over 4. Right? So 49 over 12, you divide it by 3. And, divide it by, I'm dividing by, what? Not that, it'll be 36. Sorry, what am I thinking? Flip and multiply. So it would be like timesing by a third. So yeah, it should be 36. Sorry about that. Okay, so there we go. And then, running out of room. Maybe I'll just shove a few things up. Move that up there. Give ourselves some room. Okay. And then, at this point, we're going to square root both sides. So when we square root the left-hand side, we get x minus 5 over 6. Now, remember what I told you. If we square root 49 over 36, that's the same as square rooting 49 over square rooting 36, which is equal to 7 over, 36, yeah, which is 7 over 6. Okay, so we should get 7 over 6, but why don't you just check on your calculator to see that I'm not lying to you? I mean, I shouldn't. I can get things wrong. Okay, 7 over 6 it is, right? And then we move that. Oh, and it should be, when we square root it, it should be plus, so it should be plus or minus 7/6. So I'll move that over because we're taking the square root. So we get x is equal to 5/6 plus or minus 7/6. And we're going to have a couple of answers there. Move this out. We'll get x is equal to, what's that, 12/6, which is 2. Or if we take away the 7/6, we'll get negative 2/6, which is negative 1/3. So 5 plus 7 is 12. 12 over 6 is 2. 5 minus 7 is negative 2. Negative 2 over 6 is negative 1 over 3, or negative 1/3. All right, one more here before the word problem. We're meant to complete the square to solve this. So what I would do here is I'd first expand. Okay, then I'd complete the square on the left-hand side, which is like this. Okay, now let's just quickly check. What's that? When we expand it, it's x squared minus 4x plus 4. And if we have that takeaway 4 out there, that will give us this, which is what we want here. Okay, so that's just a refresher on the old, the old completing the square. Okay, now I'm going to pull that 4 across to the other side by adding it. So I should get this. I'm going to square root both sides, so I should get plus or minus the square root of 24. Now, let me see, that's like the square root of 4 times the square root of 6, right? 4 times 6 is 24. So on your calculator, when you do this, when you do square root 24, it will give you 2 square root 6, okay? That's a little extra tip for you geniuses. Okay, we're going to go x equals 2 plus or minus, now what did I say, 2 square root 6. Or square root 24, it's the same thing, okay? And then we get our two answers. So what's that? So 2 plus 2 square root 6 gives me 6.90. 90 to 3 significant figures. Or if we do the 2 takeaway 2 square root 6, that gives me negative 2.90. Okay, those are the two answers there. Now finally, I'm going to just quickly use completing the square to find the minimum value of this. Now, this is a little bit different, but it's a really useful skill to have. So remember, if you've got a positive x squared, you know that it's a valley shape. So there's a minimum value, and the minimum value is at the bottom of the curve here, right? But that'll be the lowest it possibly goes on the y-axis. Okay, so what we can do to complete the square is we can write it like this. Y equals x squared minus 4x plus 11. And we can go y equals, and then we start completing the square. So it would be x minus 2 all squared minus 4 plus 11. Then we add the minus 4 and the 11. That gives us plus 7. Now, how this works is that we can now tell where the minimum point is. The minimum point, minimum, is at 2, 7. Okay, now I'll explain why this is. When you square a number, so this number is going to get squared, you always end up with a positive number or 0. Okay? Square anything, it will be positive or 0. So the lowest value for y that you can possibly have in this whole equation is when you get a 0 in this bracket here. Okay? Because you can't get into the negatives. So what you do is you look at how can I make this bracket equal to 0 when I square it. And the answer to that is 2. Right? Now, when you put 2 into that bracket, what's your y value? Well, 2 minus 2 all squared is 0, right? 0 squared is 0, plus 7. So that 7 is the minimum point that that you can get out of this equation. Well, I know that's a little bit tricky. There are a couple more that want you to do similar sorts of things using completing the square. This will become a big skill that you need to be able to use next year in year 11. So it's good to try and get a handle on it now. Well, I hope this hasn't been too long. I hope you are starting to feel more comfortable with completing the square. And you can get into that exercise and do as much as you can with the time that you have left. And feel free to ask questions. I'll try and get to them as soon as I can. All right, team. God bless.